So hi, welcome to the worksheet 11 solutions. I'm going to make this part 1 because it's going to be quite long. So on the questions from sets, we started off with A is equal to the set of order, chaos, and neutral. So if you remember, the power set of A is the collection of all subsets of A. And so that definitely always includes the empty set, and it's also going to include A as well, which is the biggest set inside of A. But there's other sets as well. For instance, the sets of one element, so this order, this chaos, and there's neutral. But then there are the sets of two elements, so order, chaos, order and neutral, and chaos and neutral. And finally there's the set of order size 3, which is A itself, order, chaos, and neutral. So if you count, there's 1, 2, 3, 4, 5, 6, 7, 8 elements total. And that's 2 to the 3 because the size of A was 3. An important thing to note the set of chaos and neutral is the same thing as the set neutral chaos, because if you remember, the order doesn't matter when we have set notation. So for question 2, we had that x is the set of real numbers such that -1 is smaller or equal to x, smaller or equal to 2, and y is equal to the set of real numbers such that 0 is smaller or equal to y, smaller or equal to 5. And here, notice that these are just dummy variables. This explanation refers to that x, and this explanation refers to that y. If you drew a picture of the real line, remember it goes off in both directions. Say there's 0, let's say there's 5, there's -5. Then x is between -1 and 2. So x, let's say that's in blue. It's everything in here. And y, let's say it's in red, is everything between 0 and 5. And know that it's not just the numbers 0, 1, 2, 3, 4, 5 for y, it's everything in between. Lots of numbers, uncountably many. So we're asked how to describe x intersect y, x union y, and x less y, or the set difference of x and y. So here, these are the elements in the real line such that it satisfies both this and this condition using this dummy variable. So it's between -1 and 2, and it's between 0 and 5. So in the picture, if I draw in the green, it's both conditions, so it's that intersection there. So this is the same thing as all those real numbers, such that it's between 0 and 2. Now if you take the union instead, so this time let me pick orange, those are any numbers which are in x or in y, so it's all numbers between 0 and 5. Oh, sorry, so between -1 and 5. Excuse me. So it's all of those, including the endpoints. Now, perhaps the most subtle one is the set difference, x minus y. So those are all elements which belong to x, but not belong to y. So not of the following condition. So in the picture above, the valid part, let's draw it in yellow. So it's those numbers in yellow, but not 0, because 0 is in y. So if I draw the answer first, it's all of these, but not 0, so these numbers. And so this is the set of real numbers where -1 is small or equal to x, but it's strictly less than 0. So for question 3, where u is equal to the set of car, plane, car. But notice here, car is repeated, and so u is just the set of car and plane, the set of size 2. And v is equal to plane, banana, orange. So notice that plane is common to both u and v. Therefore, the regular union u union v is equal to car, plane, banana, orange. We're allowed repeats, but they only count once, and the size or cardinality is 4. The disjoint union, however, must be size 5 because there's 2 in u and 3 in v. And how do we make the disjoint union? So we make the union of the tagged sets. Where u star is equal to car, and we tag it with tu, and plane tagged with tu as well. And we distinguish v star as plane, tv, banana, tv, and orange, tv. And we have 5 elements, so that u plus v is equal to u star, the regular union with v star, and we have 5 elements. I'm just going to write the first and the last one. You should fill them out. There should be 5 terms total, and the size of u plus v is equal to 5, because there's 2 in u and 3 in v. And they're all different when they're made into u star and v star. So let me do the number section next, and then continue the next time. So question 4, we have that 14 is equal to 2 times 7. That's the prime factorization. 21 is 3 times 7. And so the least common multiple, LCM, is the smallest number which 14 and 21 both divide into. And see, we need 2 times 3 times 7. So that's equal to 42. And the greatest common factor, that's the biggest number which is a multiple in both of them. So this time it's 7, and that's it. Remember that the product of these two numbers is actually the same thing as the product of the least common multiple and the greatest common factor. So question 5, 41 div 7 is the number of 7s in 41, and so that's 5, because 6 7s are 42, and that gets too big. And the remainder, well, that's 6, because 5 times 7 plus 6 is equal to 41. So what are the decimal and binary forms of the hexadecimal A38? You remember that there are 16 digits, that in hex you have the regular decimals, so you've got 0, 1 up to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but you also have A, B, C, D, E, and F, where A is equal to 10 in decimals, B is 11, and so on, all the way to F, which is not 16, but 15. And so A3816 is equal to, well, let's just do the digits first. So A16 is equal to 10 in base 10. 3 in 16 is 3 in base 10. And 8 in base 16 is also 8 in base 10. But we're going to write these out in base 2. So 10 is equal to 8 plus 2. And so that's 1010 in base 2. Remember the way to think about it here, that's 1, 2, 4, and 8. And similarly, 3 is 0011 in base 2. And 8 is equal to 1000 in base 2, 1000. So in base 10, what we have is that A38 gives me 10 times 16 squared, because this is the third digit along. You should think here we have 1, 16, and 16 squared. And so we had 10 times 16 squared plus 3 times 16 plus 8 times 1. And so what we get is 2616 in base 10. Do a little bit of multiplying out. And the binary is just collecting all these, and that's easy. We just get 1010, 0011, 1000 in base 2. And so finally, question 7. Having a little bug here. If 3 to the 9 is equal to 19683, then this is, remember, this is the base. We have that log to the base 3 of 3 to the 9 is equal to log to the base 3 of this big number, whatever it is, and therefore we get that 9 is equal to log to the base 3 of 19,683.